Hi guys, today we're going to be solving systems of equations in 3 variables. And so the variables that I'm dealing with here, x, y, and z, you'll notice that I have my equations kind of tucked over in the corner here. I got all this space out here. Well, the reason for that is I'm going to be using all that space to solve these equations, okay? So the first thing I'm going to want to do is I want to label these. I'm going to call the first one A, the second one B, and the third one C, just so we can keep track of which equation we're dealing with, okay? So if you know anything about solving systems of equations and linear combinations, you'll know that it's important to find something that you can cancel. Well, if I look at these right away, I see that I can cancel those x's. So what I'm going to do is I'm going to bring down equation A as x plus 3y minus 4z equals negative 16. And equation B, so I'm rewriting them down here, minus x minus 2y plus 3z equals 11. So let's do linear combinations, and my x's cancel. So then I have 3y minus 2y. Well, that's just y, right? And then I have negative 4z plus 3z. Well, that's minus 1z, or just z, equals negative 16 plus 11 is negative 5. All right, now I'm going to label this equation D. All right, that's equation D. Now I'm going to take equations B and C, and I'm going to bring them down here. B is negative x minus 2y plus 3z. You'll notice I'm putting dashes through the z's to separate them from the 2's. That's why I'm doing that, in case you were wondering. Equals 11. All right, now I'm going to bring down C, okay? So I got 4x minus y minus 6z equals negative 5. Well, I canceled the x's right here. So I'm going to want to cancel x's right here. So the way I'm going to do that is I'm going to multiply my top equation by 4. Okay, so I'll do 4 times that, 4 times that, 4 times that, and 4 times that. So that gives me negative 4x minus 8y plus 12z equals 44. Well, I see that my 4x minus 4x cancels. All right. And I'll have negative y, negative 8y, that's negative 9y. And then I have negative 6z plus 12z, and that's positive 6z, equals, well, negative 5 plus 44 is 39. And I'm going to label this equation E. Well, up here, I'm going to write equation D and E. All right, so that's y minus z equals negative 5 and negative 9y plus 6z equals 39. All right, so now I want to cancel the y. All right, and I'll notice that all I have to do to cancel the y is multiply the top by positive 9 so that they will be opposite. Okay, so I can cancel the y. So I have to do distributive property. So I will bring that down underneath here. I have 9y minus 9z equals negative 45. Right? And we'll do linear combinations on this, and my y's cancel. So now I have 6z minus 9z, that's negative 3z, equals 39 minus 45 is negative 6. Well, solve for z. I'm going to divide both sides by negative 3. So z equals 2. All right, so we found z. Now we need to go in and find x and y. So what I'm going to do is I'm going to take this z and I'm going to plug it into this equation right here. All right, so it becomes y minus 2 equals negative 5. So now I add 2, those cancel, and y is negative 3. So now I have the value of y and z. So I need to find x. I do not know what x is right now. So what I'm going to do is I'm going to choose to plug them into the first equation because there's an x by itself with no coefficient other than 1. So what I'll do is I will rewrite the equation over here, plugging in the values of z equals 2 and y equals negative 3. So now I have x plus 3 times negative 3 minus 4 times 2 equals negative 16. All right, let's simplify that. X minus 9 minus 8 equals negative 16. Well, I can combine my negative 9 and negative 8, so that's x minus 17 equals negative 16. If I add 17 to both sides, those cancel. X equals negative 16 plus 17 is 1. So x is 1. So that means that my solution is in the form x, y, z. My solution is 1, negative 3, 2. Now, if you wanted to check this, you could plug each of these values into the original 3 equations just to make sure they work. And that's how you check to make sure that your answer is right. But the way you solve this system of equations in 3 variables is like this. So our final answer is 1, negative 3, 2.